sorry, let me start the recording. Yeah. So when we want to send out a notification from within an instance, for example, a composite is deployed to SO infrastructure and we invoke the composite. When we say invoking the composite, it's what we mean is we invoke the service offered by the composite. So when we invoke the service offered by the composite, we know an instance gets created. So the instance basically calls a series of services, one after the other. During these calls, there may be a scenario where the instance wants to send out some kind of alert message, some kind of notification, some kind of information. It can be anything. It can be anything. So when such a requirement is there by instance, instead of writing the code within the instance itself, we are going to use the user messaging services offered by the server infrastructure. So server gives you an ability to send out notifications, or the user messaging services within server gives the ability to send out the notification. Means you don't have to worry about the code. How should I connect to backend server, or how should I connect to emails? This is pretty much similar to what a data source does in WebLogic. Data source basically relieves an application from the worry of how to connect to a database. In a WebLogic environment, if an application requires a connection to the database, the application need not worry, how should I connect to the database? What are the usernames, password? How should I manage those connections? What happens if something goes wrong with the connection? What should I do? Those things need not be worried by the application. They're all taken care by the data source. The same way here, if an instance wants to send out an email notification, it does not have to worry about, okay, which SMTP server I have to connect to. Where should I, send my message? What will happen if, the email ID is wrong? How many times should I retry resending it? All those things need not be worried by the instance. They will be taken care by what is called our user messaging services. So the developer can pretty much use the JDeveloper. Just say that, okay, this is a message, I want to send it to this address. That's it. Other than that, how we are going to send it, which server we're going to connect, the developer need not worry. So the instance, if you look at this diagram, on the left side, you're looking at instances. These are the instances running on your SO infrastructure. Now, when these instances want to send out a notification, they will usually send it out using a gateway like email provider. Like for example, if we want to send out a notification, we will be using Microsoft Exchange server in your offices. And same if this instance wants to send out a notification, there is a slight disturbance somewhere. Is it from me? Okay, I'll try to fix it. So when these instances want to send out notification, they ideally need to connect to this gateway. Any kind of notification. You got lots of types of notifications we can send out. We can send out email based notifications. You can send out SMSs as alert messages. You can send chat messages like Gtalk, Yahoo Messenger, Facebook chat, all those kind of messages. So in a company you are using probably Microsoft or this Office Communicator, or a lot of people also use a lot of kind of tools. Yesterday I went to that some other training, they were using something like IP Messenger. It's a LAN based communication tool. That was pretty good. most of us will be using MS Office Communicator. That's what we use. Then you have voice XML. It's like you want to send out a notification, or you want to get a physical call if something goes wrong. Then there is a proxy also, we will come there. So there are lots of types of notifications we may want to send out when something happens in the instance. For example, if you take the eBay instance that we always talk about, if the delivery is done, we want to send out an email to the end user that okay, you received this item, please log into the website and give us your update. Now that's part of the instance step-by-step process itself. That's an email card. So here the instance need not worry about how to send out that notification. To do that, it will be using the infrastructure that we are seeing here. In the infrastructure, you are seeing the main thing is UMS server, which is the one that will be taking care of connecting to the external gateway, sending it. But to connect to the UMS server itself, the instances are going to use the adapters. So adapter is a rare file that lets an instance connect to a UMS server. And inside the UMS server, you have this architecture. We'll see this architecture, what it is. Then the UMS server lets you connect to a gateway. The gateway is the one that sends out any kind of notification. Depending on what type of notification we want to send out, we will be configuring the corresponding gateway. Now let's see a little bit in depth into UMS server. I'll come back to this. Why EMS? This is what UMS is. This is one block that I'm talking about. See this then? The UMS server previous sheet. This block. Hold on just a minute. Let me use zoom it. That's it. Downloads. So see this one. This is the UMS server. This is the UMS server we are talking about. These are the instances. Now the instances will connect to the UMS server using the gateway. Now the UMS server itself has an internal architecture. We don't really, we'll never really be going into that. You never would need that. But this is the architecture inside the UMS server. These are the drivers that will let you connect to external gateways. This is an SMTP driver or email driver. SMTP is Simple Mail Transfer Protocol. We'll see about the protocols in just a moment. So we have a driver to connect to a corresponding gateway. Now here you are actually going to have a gateway here. So this is going to be email gateway like that. Then there is going to be a SMS gateway. Then there's going to be a XMPP gateway for internet messaging. Then there is going to be a voicemail, means for sending out voice-based automation messages. Then there is going to be a proxy gateway. Proxy gateway you will use usually. Okay, a gateway. Okay, gateway is something like, let's say, payment gateway. If you are purchasing something on eBay, when you say pay now, you get connected to a gateway that will process your credit card. It will validate it. So what a gateway is doing there? Can you tell me what a gateway is doing there?
Hello.
Yeah.
Yeah, hi sir. This is Kalyan. Actually, it sends to the third-party credit card authorized companies so that they can get back the validated information from them?
So gateway is something, usually checks whether the external system is available or not. It processes your information. It takes your information, process it, then tries to do something with that information. So gateway is basically entry into something else,
Okay.
isn't it?
I
Now,
see.
if I say email gateway, what I mean is I'll give my message to a server or a software called gateway software. The guy is supposed, or that software is supposed to check whether my email ID is proper or not, whether the message that I'm sending is proper or not, and then try to send it to the email that I have given. So let's say, for example, if you are saying you want to send it to weblogic.anil@gmail.com, you are connecting, let's say, from a different email provider like Yahoo, kalyan@yahoo.com. If you say, now the yahoo.com is the gateway. What it does is it first checks, okay, what is the to address. Okay, it's supposed to go to weblogic.anil@gmail.com. So it will first check whether there is a domain called gmail.com or not. Now once it checked, it will contact the SMTP server of Gmail. It checks, okay, we want to send out a notification, we want to send out email to weblogic.anil. This is the message. Now the Gmail SMTP server will respond back saying, okay, give us the message, or this my email ID does not exist, or anything. In that case, your gateway was the Yahoo server, or Yahoo mail server was your gateway. The gateway basically takes your message, validates it, and it processes so that it can be sent out, or it can talk to another software. That's what a gateway does. The best example is a payment gateway. Now in the payment gateway case, let's say you are using one kind of Citibank credit card. We are not connecting to Citibank website directly. Citibank itself does not have anything to do with at that point of time. So there is something called a software called a gateway software. The gateway software can be anybody's, any company provided software. Usually you will see in India, if you see, the gateways are, especially ICICI Bank, there is a gateway. Citibank, there is a very good gateway. HDFC Bank provides a gateway. Axis Bank provides a gateway. These are the four major gateways. You are using anybody's card, you have to go through these gateways. They will validate your card. They will check your, they will talk to the actual bank or visa, and they will see whether you have enough balance or not, or your credit is available or not. Then they say yes or no to your transaction. So a gateway processes your data. That's what a gateway is. All right, excellent. Now here, just like a payment gateway, you have lots of types of gateways to do a lot of types of things. SMTP gateway, that's for sending emails. If you see the last slide, we are looking at two different things. See this one. There are boxes here. These are inside the UMS server. We will be talking about them later, but currently we are talking about a gateway which is outside our environment. The gateway is not something that we have inside our server. So we will be talking to one of an external elements called email server, which is usually SMTP. Same way SMS, XMPP, voice XML, proxy. These are, now a proxy gateway here is, now a lot of times an instance when wants to send out a notification, one way is to use one of these things directly. These gateways send out notification, but sometimes we may also want not to directly use the gateways connected to our SOA. Let's say there is another somewhere else SOA infrastructure. There is a UMS server on that SOA infrastructure. We want to send it through that UMS server, which means the one that I'm using here, my UMS server should connect to another UMS server which is available here on the right side. So I have to connect first to this. So I have to connect first to this, and then to this. So the gateway I'm using becomes a proxy here. In this case, this one becomes a proxy because I'm not directly sending a notification through the server that I'm connected to. I means the instance. So the instance is not directly using any of these top 4 gateways. Instead, there is the similar setup somewhere else through that setup. Now this will be used especially if you have large SOA servers, large number of SOA servers. Now if you have large number of SOA servers, instead of configuring gateways at every server, you will simply configure a proxy gateway, and finally there is one SOA server that will send out to the external world. Now if you see this architecture, I have drawn gateways on the right side, and then there are also boxes inside the UMS server. This thing. Now these boxes are actually drivers. Drivers means this box will have all the information need to be connected to the external gateway. Means what is the host of the gateway, what is the port number of the gateway, what's the username to connect there, what's the password. All that information is stored in the driver. Now obviously for each type of gateway you have one driver, and it's the driver that manages the connection to the gateway. For example, managing the connection means, let's say we want to send out the notification. Assume the gateway itself is down. What are we going to do? Are we going to retry it? Are we going to abort it? Or if we have retried, let's say how many times we're going to retry. What am I supposed to do if the gateway says the username password is wrong? So that kind of connectivity to the external gateway is managed by the driver. So the driver knows the language of the gateway. How should I talk to the gateway? What language I should talk to the gateway? How should I deliver the message? How many times I should retry? All those things are configured in driver. So you have drivers for all the 4 types or 5 types. So there is an email driver, SMS driver, there is a XMPP, which is for internet messaging, chat messaging. Then there is a voice XML for voice-based calling outs. Then there is a proxy driver. These are the drivers that I was showing in the previous one. You see, this is inside the UMS server. Just next to these boxes is what you have the gateways. These are the gateways. Each of these gateways, the driver let you connect. Here. Alright. So now apart from the drivers, you also got a small buffering mechanism inside the UMS server. Instances, when they send out notifications, all the messages will be stored in an inbound queue. The UMS server will process the incoming messages. It will deliver it to the corresponding driver. But even not to choke up the drivers, there is a buffering mechanism on the outgoing queue also. From this queue, the messages will be picked up by the corresponding drivers. Alright, this is inside of the UMS server. These queues are already created when you have created a server domain. Now, so when we start the server, we actually bring up this entire setup. Now, to connect to this setup, or for an instance to put a message in this JMS queue, it has to use what is called an adapter. This is what you looked at. This is an adapter, a RAR file. So this RAR file has to be deployed. Now, once this RAR file is deployed, the instance will be able to communicate with the UMS server, put the messages into the buffer, the incoming buffer here. This is the actual UMS server. It takes your message, sees where it should send it to. This is the outbound queue. It will be sent to the corresponding driver. The driver has information about the gateway. It will send it to the gateway like this. and the gateway will send it to the external world, wherever you want to send it out. That's the process that's happening here. Now, as an administrator, your job is to configure the UMS adapter. This you have to configure. This entire thing. Then you have to configure all the drivers, which means you should have the information of the gateway, put that information into the driver. That's what you're going to do. Everything else is ready. Now, before we do that, the instances should know how to connect to the adapter. So we're going to do this entire setup in a couple of steps. But before we go there, let me just go through the doc that we have, why we are using the entire thing. Then we'll go into the configuration part. I'll quickly go through that one. These points, we have already discussed these points. Now this is why we need UMS. When an instance wants to send a notification or any kind of alert, they can use out-of-box messaging system. It's already available. The instance does not have to worry about how to connect to the external system. What's the username, password, or that's headache of the SOA. The instance simply says what type of message and what is the message. That's it. And do not worry about how to send it or what to do if the sending fails. That will be taken care by the user messaging services part or UMS server part of SOA. Obviously, that's what we are talking about. Composite need not worry about how to send an email or an SMS or chat message or make an automated phone call. It will be taken care by the UMS system. A third point here, instances, they simply connect to the UMS server and give the message. That's it. The message delivery responsibility is taken up by the UMS. It's the driver who takes care of delivering the message. It guarantees the delivery if the gateway is responding. Now, why we need UMS is because of these things. These are the technical reasons. We don't want to code sending related information in the composite. So we want to separate the implementation of notification from the composite code. That's what UMS does. It takes care of buffering messages and configuring drivers of various protocols. All this driver configuration will be done outside a composite. The composite itself need not worry about the implementation or connections to the external world. The message retry, this is what we were talking about. Should I retry if the gateway is not available? Or should I redelivery? How to handle the delivery failures? All of them will be taken care by the EMS server. Now, this is also another point. If the gateway itself changes, it will not have any impact on the composite coding. But if we do the coding inside the composite, every time a gateway changes, it will directly impact. Let's say currently I am using a Gmail gateway, and if the Gmail gateway I did not like because it's blocking all my messages saying that it's spam. Some gateways are strict, some gateways are loose in way of sending messages. Let's say if you have you're trying to send an email message. For example, your office emails, office servers of all our Exchange servers, very strict. They implement very strict restrictions. For example, anything, any word, they go through the content that you are sending, and if they match any of the restrictions, it will not be sent out. Like let's say you put in any obscene words in it, then it's not going to send out that notification. Anything like porn or abuse or sex, anything you put it detects that the message as like spam or malware kind of thing. Let's say you attach a .exe file, your SMTP server says this is a possible virus. You're not expected to send out .exe files. Those are usually malwares. So SMTP servers some servers are strict, some servers are loose in their way of interpreting the message. Now, if you don't want one SMTP server, you may want to switch to another SMTP server. In that case, because of the UMS, the switching does not have any direct impact on the instance. Alright, that's, you can change the gateways, you can change the configuration simply in the drivers. This is what is our internal structure of UMS. Now all that you will be doing is configuring the drivers, and you will be deploying the adapter. So there is one thing here, then any driver that you want, you will be deploying. We will see obviously the deployment of the UMS configuration in our implementation. Apart from that, we will also see two types of gateway configuration. We will see email gateway configuration. We'll also see chat message type gateway configuration. Other than that, we won't have any other infrastructure to check the SMS gateway and voicemail. They are pretty much same. Once you know these two, the other you will be able to configure. Now before we go in there, let's look at the protocols that I am talking about. The gateway protocols and how what type of protocols these notifications are used. If it is email, you will be using a simple mail transfer protocol and obviously an SMTP gateway. Email works on SMTP protocol, simple mail transfer protocol. So the protocol says what should be the message structure. It's like, you should have a from address, you should have a to address, you should have a subject, that should be a body. That's what the SMTP protocol says. It gives the structure. Then SMS. It is actually based on SMPP protocol, which is called short message peer-to-peer protocol. You don't have to remember the expansions of these protocols, but if you do, it's good. Then there is a internet messaging chart. This is usually done by XMPP protocols, the extensible markup and presence protocol. Earlier, this XMPP was called Jabber protocol, Jabber. So you will come across this word Jabber also. When you come across this word Jabber, so it actually means internet messaging. So basically what happens is a Jabber protocol, or let's for example Google Talk. You are connected to Gtalk, I am connected to Gtalk. There is a Gtalk server like this. The Gtalk server, you use Jabber in Office, excellent. So that's basically internet messaging. There is a Jabber server somewhere, so in your office. So this is XMPP. So what we have here is we are connected. You are connected here, I am connected here. The Jabber server lets us talk to each other like this. When I put something in, the Jabber server takes it to your instance session. When you put something in, the Jabber server takes it to my session. It's like this is all done by the XMPP protocol. And the chart that we are using here, it actually uses the XMPP of the GoToMeeting, this thing. And that's your protocol for internet messaging. So all charts services use the same XMPP protocol. Gtalk, Yahoo Messenger, Skype, anything you take. Apart from this, then a final voice XML is another protocol. It's for making automated phone calls. Like let's say a notification we want to send out, your item delivered, but instead of sending an SMS, we want to make a call to the mobile number that's given and deliver the automated message. This is usually used for highly critical alerts. Like for example, our cloud server. We have our cloud server, right? So there is a alert messaging on the cloud server. If the cloud server goes down, means there is a website. The website simply has a tool that pings the cloud server. If the ping has failed, the website is expected to give me a call. So I get a call when the cloud server goes down. The reason why I wanted a call is I miss a lot of SMSs. Obviously, I cannot always keep look at my email when you're outside, when you're in office. I can't keep looking at emails. So SMS is also something that I miss sometimes. So a call is something that I never miss. When I get a call, I know, okay, who is calling. So when if I'm getting a call as an alert, so that's good. So I know immediately that it's down and I can do something about it. So voice XML also, some people use it for especially very critical